Now, circular current loop as a magnetic dipole. Okay. Say, we already derived the equation for the magnetic field on the axis of the circular loop of radius r carrying current I. That is B at x equal to mu 0 I r square upon 2 into r square plus x square raised to 3 by 2. Now for x is very much greater than r, we write B at x, that is mu 0 I r square upon 2x cube. Now here we want to represent it as a magnetic dipole. So equation of its magnetic field, if we represent in terms of magnetic moment, then we can say circular loop, that is as a magnetic dipole. So to introduce magnetic moment here, magnetic moment, that is I into A, area of the loop. So here multiply and divide by pi. So we can write mu 0 I into pi r square upon 2 pi into x cube. So B at x, that is mu 0. Now pi r square, that is area of the loop. So that is I into A upon 2 pi x cube, but I into A, that is the magnetic moment. So B at x, that is mu 0 m upon 2 pi x cube. Now rewrite this one. Here multiply and divide by 2 again. So we can resultantly write mu 0 upon 4 pi 2m upon x cube. Here see, the constant appears, that is mu 0 upon 4 pi. In case of electric dipole, we can write the equation of the electric field at any point on the axis of the dipole, that is E axis equal to 1 upon 4 pi epsilon 0 2p upon x cube. P, that is dipole moment, here m, that is dipole moment, and the constant in electrostatics, that is 1 upon 4 pi epsilon 0, and in magnetics it is mu 0 upon 4 pi. Okay, so if we consider the circular current loop as a magnetic dipole, then we can write the equation of the magnetic field at any point on the axis of it, that is this one. So from this analogy, now directly we can write the equation for the magnetic field at any point in the plane of the loop. Axis is perpendicular to the plane of the loop, and in the plane of the loop, so we can consider it as equatorial plane. Now see, in case of electric dipole, at any point on the equatorial plane, E equatorial plane, that is 1 upon 4 pi epsilon 0 p upon x cube. So from this analogy, directly we can write the equation for the magnetic field at any point in the plane of the loop. So that is mu 0 upon 4 pi. This constant is replaced by mu 0 upon 4 pi. Here electric dipole moment, here magnetic dipole moment upon x cube upon x cube. Clear?